The theme of my presentation today is focused on mechanics involved in utilizing segmented arch without brackets. I do not have any conflict of interest to disclose. The segmented arch technique was developed by Dr. Burstone in the 1950s. Perhaps the T-loop spring is one of the most famous appliances associated with this technique. However, it is not used widely anymore. Nevertheless, it does not necessarily mean that the segmented arch itself is obsolete. In bracket-free treatment, flowable resin is used to attach the wire directly over the teeth, while the conventional brackets and tubes are still used in the buccal segments for convenience. This idea was first published by Dr. Musili in 2008. Note that two different wires, such as rectangular and round wires, are connected at the canine. Segmented arch means arch wire is disconnected so that whole arch is divided into segments. What is the reason for using a segmented arch? It is my contention that the inadvertent use of continuous arch wire may create more problems than it can solve. Once the brackets are bonded to the crowded teeth, the amount of activation of wire is determined based on the position of the bracket slots and cannot be altered, and the wire needs to be replaced with a stiffer one sequentially. Let's do a simple thought experiment. In this simple crowding case, for example, a wire is inserted and activated. Let's suppose ideal force level is 100 and it is activated to produce 200 of the force level, which is considered excessive. Therefore, the force magnitude seems too high with this wire. There are some solutions that can be considered in order to reduce the magnitude of force in this situation. These may include increasing the inner bracket distance, reducing the amount of activation, utilizing a more flexible material, or reducing the cross-sectional size of the wire. However, it is not feasible to increase the inner bracket distance or reduce the level of activation in continuous arch wire. The only remaining options are to reduce the stiffness of the wire by decreasing its modulus of elasticity, for example, by replacing the stainless steel with night tie or using a smaller cross-section of the wire. This means wire replacement is inevitable. So the wire was replaced with a more flexible one in order to ensure that the force magnitude remains within the optimal range. As the wire flattens out, the tooth approaches its final position. However, the force magnitude drops into the subthreshold level, where the tooth movement can hardly occur. Theoretically, it may not reach the final position unless force magnitude is restored with stiffer wire.